In this video, we're going to take a look at some of the problems associated with acid deposition. We're also going to look at some of the methods to deal with acid deposition, as well as to reduce sulfur dioxide emissions in our environment. So let's start out with problems associated with acid deposition. Well, we're going to look at four in this video. So the first we're going to look at is effects on vegetation. We're also going to take a look at what happens to lakes and rivers and why this is an issue. We'll look at what could happen to buildings with acid deposition, and then as well as the impact on human health. So let's start with vegetation. And so, with vegetation, when we have acid rain, for example, the acid itself, whether it's sulfuric acid or sulfurous acid, nitrous or nitric acid, any of those acids can displace the metal ions. And the most popular metal ions here are calcium, magnesium, and potassium. And they can displace those metal ions from the soil, and when they displace them, consequently, they are washed away. And the problem with this, especially with magnesium ions, is that magnesium is needed to produce chlorophyll. And so, if plants are not able to produce chlorophyll, then that can affect its ability to be able to do photosynthesis. And so, that is a major, major problem. Acid rain can also cause aluminum ions, so Al3 plus ions, to dissolve from rocks. And so when this happens, that can damage the plant roots. It can limit the water uptake in the plants. And so what results from this is you get these areas of just, vegetation and trees where the leaves are either all gone or they're yellowing because of the lack of chlorophyll here. So it's not good. All right, let's talk about lakes and rivers then. So, lakes and rivers, aquatic life is actually very, very sensitive to pH changes. And so, if the pH falls below about 6, aquatic life can be very, very sensitive to that. And not only that, if we go below 5.2, then that's when things start to die. So, insect larvae, fish, and invertebrates, they can't survive at a pH below 5.2. And below a pH of 4, there's virtually no life that will exist in lakes and rivers. So, this is a massive, massive issue. And not only that, but acid rain can actually dissolve hazardous minerals from the rocks, which can then also accumulate in lakes. And then that also contributes to the loss of aquatic life. For example, aluminum ions, which we talked about in previously in the last slide, where the acid rain is dissolving that from different rocks, that can actually damage fish gills. And so then that damages the fish, which then affects their quality of life. And we end up with these lakes with just a lot of dead aquatic life, which is, again, not very good. All right, buildings. So a lot of buildings are composed of limestone and marble. And you can see some of the damage of acid deposition over time on this particular statue here. If you look at the details on the left, you can see they're quite clear. And then over time, this is what's happened with acid deposition, is that it's actually eroded that limestone or marble away by that acid rain. And the reaction that's happening here, limestone and marble are also technically calcium carbonate. And so when that reacts with sulfuric acid, that's going to produce calcium sulfate. It's going to produce water, carbon dioxide. So it's actually eroding away the calcium carbonate here. Finally, the last impact is it can have an impact on our health. And so acids themselves will irritate mucosal membranes. They can cause respiratory illnesses. So things like asthma and bronchitis will become more prevalent in areas with greater acid deposition. Acidic water can also dissolve some of the heavy metal compounds. and can release ions like copper, lead, aluminum, and those have been implicated in many human diseases. For example, one implication is around the development of Alzheimer's disease. And so, again, deposition can have quite an impact on our human health. So, how do we deal with acid deposition? Well, one there are many, many ways that we can deal with it. So, first off, we can try to decrease the amount of acidic gases that we are pumping into our environment. So, we can do things like improving vehicle engine design. So, we're not getting those nitrogen oxides being pumped into our environment. We can use things like catalytic converters to help with the sulfur. We can remove sulfur before burning fuels so that they're not causing as many sulfur dioxide gases to be produced. We can use renewable power supplies. We can make greater use of public transportation. So, again, minimizing how many pollutants we're putting into the air. And then we can also design more efficient power stations. So, getting away from the power stations that require the sulfur because they are fueled by coal. And finally, one example, and this is shown in this visual here, is that we can also work on liming our lakes, is what it's called. And so, what they do here is they take calcium oxide, and so that's what's being put into the lake here. And that will react with the acid in the lake to form calcium sulfate and water. So, effectively, it's almost like it's neutralizing the acid within the lake, therefore bringing down the pH value. You could also do a similar reaction with calcium hydroxide with the sulfuric acid, and that is a neutralization reaction. So, very similar effects from both of those chemicals. And so, that's what's being put into the lake here so that it can react with any excess acid in the lake water. Finally, just sort of looking at reducing sulfur dioxide emissions, there are a couple ways we can reduce sulfur dioxide emissions. We can reduce it pre combustion. So that means removing the sulfur before combustion, or we can do it post combustion, which means removing the acidic gases or the sulfur dioxide after combustion. Looking at before combustion, we can look at this process. It's called hydrodesulfurization. And so, what this involves is you would heat the crude oil fractions with some hydrogen in the presence of a catalyst, and that's going to convert any sulfur in there to hydrogen sulfide. And so, then the sulfur is not available to be converted into sulfur dioxide. And what's great about this hydrogen sulfide can be removed and then it can be recycled back into sulfur again. So, this is a very sort of sustainable practice. And if we look at post combustion, so this is desulfurization, commonly used in coal fired power plants. And what they do is they take the exhaust gases from the furnace, so that would contain sulfur dioxide in those gases, and they put it through a vessel that contains alkalis or bases. And so the sulfur dioxide, instead of being pumped out into the environment, will then react with one of the alkalis or bases they use. So they use sometimes calcium oxide, calcium carbonate, or calcium hydroxide. And so it removes the sulfur dioxides from those gases before they get then released into the environment. So that's it for this video. We looked at effects of acid deposition on a variety of different factors. And then we also looked at ways that we can reduce acid deposition and sulfur dioxide emissions in the environment. That's it for this video then. Let's move on to our next task.